Good morning to all and welcome to our third session for Asia Water 2020 Technology Symposium. Before we start, there are a few rules that we'd like to add here. All microphone and video of attendees have been muted. If you have any question, please wait for the Q&A session or you may listen down at the Q&A box. If there is any internet disruption during the session, kindly be patient and try to sign in again. In this session, we will have from Alam Sekitar Malaysia, Sdn Bhd to do the presentation. With that, ladies and gentlemen, let's welcome from Alam Sekitar Malaysia, Sdn Bhd to do the presentation. The floor is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to distinguished listeners, participants and speakers out there. And we would also like to thank the organizers for giving Asma the opportunity to talk on this topic called application of artificial intelligence in real-time pollutant load analysis. I'm representing Asma, Alam Sekitar Malaysia, Sdn Bhd. The topic that we have chosen today is in line what we are moving forward to on the digital technology. So please, I think in every challenges, there are opportunities. So we see that as the pandemic COVID-19, and we are seriously combating the pandemic, as well as we are also moving forward to make our life more livelier, even though in the situations we are facing now. So the digital technology comes as a very crucial part of puzzle of our life, we are here to hop on the digital technology and on our innovative part in combating the pollutant and the pollutions in our river. So the outline of my presentation will be introduction, embracing artificial intelligence, pollutant load analysis, that is the system Kembang which we have innovated, the real-time pollutant load analysis and output of pollution load analysis system. That is what we are going to share with you this morning. And okay, I'm going to start with the introduction. Now, as we all know, water is our lifeline, and when we talk about water, there are two issues that we have to face with water. That is the quantity and the quality. Now, in terms of quantity, we will be talking about how much is the water that we have, okay? And I think being in Malaysia, we are blessed with so much rain, and there is no problem actually in water quantity, especially this part of the season, this part of the year. Now, when you talk about water quality, there are something that we have to ask. Where is the location of our river that we are talking about? Because some of the rivers in our state are heavily polluted, some are not so heavily polluted. So I'm quoting here by Ali 2005. He says that as issues of water pollution become more critical, more countries are implementing water quality monitoring programs to control and reduce its impact to a minimum level. So this is why we need to have a monitoring program. And it's just not a monitoring program. It has to be very intensive kind of data collection so that we really can focus on sources of pollution that we are dealing with. Now, water, river, when you talk about it, it is about the watershed. It is about the component of the watershed. So we all live in a watershed. So we all have a role to play in our watershed management. So what I have put up here is the 4 quadrants, which are very important. Of course, the list that I have listed down here are not exhaustive, but there are things that we need to do, and we need to intensify our effort. Now, if you look at the vertical arrow, we have the high impact, and the horizontals will take you to the actions and the high outputs. Now, let's look at the community empowerment. Now, a lot has been talked about CSR project by the industries, by the NGOs, and so forth. Now, what I want to focus here is that the industries has to play a bigger role in this community empowerment, simply because what they have been doing is not enough to protect the watershed. You see? So the pandemic gives them the opportunity to pause a little bit in their business and look at what is my business contributing to the environment, to the preservation of the environment, to the conservation of the environment. So the answer is, can we change our business model or not? From linear economy to a circular economy. Everybody is talking about circular economy. And this is the best time that the industries think about how they can modify their business into circularity. Okay? Because once you are in the circular economy, there will be less waste. When there is less waste, the issues of illegal discharge, illegal dumping will be reduced. If we can change into circular economy, and also they should also look at the productivity, the production part, whether it can be green or not. So these are the things that the industry should play a bigger role to change and to play more part and role in the community empowerment, apart from what we have been doing by the NGOs and the CSR work that we have been doing. Now, if we move on to the river basin management, this is the one that gives high impact when we have actions done. Now, I just want to share with you the example on zero discharge, okay? So when we talk about zero discharge in a river basin or watershed, does it entail to we have the power to do it? Because currently we are not able to impose zero discharge because we do not know whether our actions is backed up by our legal procedures or not. So that is why we have to also look at our legal mechanism. Not only that, when we impose higher penalties, so again we have to look at now. When you impose higher penalties, that means the industries will have to defend themselves. If they have to pay ringgit 1 million of fine, I'm sure they're going to hire a lawyer to work for them at their best interest. So these are the things that whether or not our legal mechanism is in balance or not, you see. So another thing is agency enrichment. Now, agency enrichment is about enabling technologies. We have to use the technologies in order to carry out all the work that is, especially in enforcement, because we will not be able to station all our enforcement officers in every industry that is discharging or that is producing hazardous and toxic waste. Like it or not, we have to use technology. So when we have technologies, we have to have a backup instruments too, like the using the artificial intelligence, the cloud computing, and etc. Okay. Now, the next slide is what I want to share is how the knowledge frameworks works in digital technology. Now, if you look at the very bottom there, data collection. Data becomes a very important part of this whole knowledge framework. Okay, so from there, once we have data, we have to interpret the data. We have to turn the data into information so that when we have the information, we can match up with the knowledge that we have, and we can have the experts who can interpret what is the best solutions for the problems that we are facing now. So when that is done, we can always input this into an AI. So that is how the knowledge and the expertise and the data is transformed into AI. Now, let's look at artificial intelligence. Why is it so significant in environmental management? So what is AI by definition? Now, Bucci in 2009 defined as human-computer system. performs problem-solving tasks in a very specific domain. That means you design the AI for a very specific domain, and it can also be applied to environmental domain, right? Now, what is it? Can we apply? Of course, as Vidya said earlier. Now, AI is an algorithm that consists of a set of rules, a set of process for calculation, for solving problems by the computer. Okay, and this algorithm that we develop can be improved from time to time, and we can fine tune to the needs of our clients, right? Why is AI necessary then? Having said that, now AI can be used for problem solving. AI can be used in knowledge and reasoning. It can be built on knowledge and reasoning. And if there is uncertain knowledge or missing piece of information, we can build the AI and make it a learning process for the AI to improve the problem solving process. Of course, when everything is in place, AI becomes a very powerful tool in communicating and for actions to be taken. So, we talk so much about data, the importance of data. What are data then? Now, when you talk in digital technology, data is defined as the 3V: the volume, the variety, and the velocity. Now, when you talk about volume, of course, it is the quantity, how much is generated, how much it stores, okay, so that we can mine the data later on to transform it into information that we can use. Variety means the type and nature of data, okay. Data not only in the forms of numbers, in the forms of figures, but it can also be in text form, images, audios, videos, and so forth. So with all this data, it can be used into data fusions to come up with a piece of information which is the missing link in most of our process in making decisions. Okay. Now, the other way is the velocity. Now, speed becomes very important. That is why in AI, it is in real time because it is developed in terms of the frequency of data that is coming in and the frequency that you can handle, record, and you can publish whatever kinds of results and outputs that you want. Now, all in is the big data. Now, this is the big data. When you have data velocity, when you have data varieties, you have data volumes, all these are known as big data. And data must be analyzed and processed in advance and to derive at a very meaningful information. Okay, so this is part and parcel of the whole digital technology. Now, why do we need all this information then? Because we want to come up with an informed decision making. Okay, so we just do not want to have perceptions. We just do not want to have probability. This could cause this could cause that. But we want a good decision at the end of the day, so that we can protect and conserve our water. Now, the next part of my talk will be on the pollution load analysis, which is the system Kembang that we have innovated. Now, what is system Kembang then? System Kembang is an assessment tool to look into the loads and the loading capacity of the rivers using the model known as duration curve. Okay, and it is driven by the AI technology. So the system is a sophisticated tool. It is a self-learning capability to indicate the assimilative capacity of the river as well as the division of the pollutants according to the flow characterization. So it starts off with a very on a manual basis, okay, to run the model on the duration curve. And then we innovate a little bit. We put it into a real time. We put it into automatic stations and see whether or not it can generate, whether or not system Kembang can generate the result as it is. Now, if you look at what is being projected here, system Kembang on a real-time load analysis. So it is an added value and innovations that we developed in time of pandemics, and we came up with this idea, and it is a very successful, I should say, innovations in terms of assessing the pollutant load on real time. So we can say that it's a detailed twin to the conventional TMDL because it is able to assess pollutant load in real time, and at the end of the processing and analysis, we are going to integrate the system with GIS to map out the sources of the pollutants that is coming from that particular watershed. And we can also use it as a prediction model because GIS, the models that we want to introduce is the LTR model of predictions, and we are able to come up with the early warning system kind of thing. Okay, what are the capabilities of the river pollution load analysis? As I said earlier, it is real-time analysis, so it can generate the load data in real time at whatever time you wish to see what is the loading like. You can always have it on your dashboard. Now, it is capable of segregating the type of source in terms of flow pattern. Okay, you can know from very beginning that the origins of the violations or the non-compliance either can come from point source or the non-point source. Okay, and non-compliance, of course, from there we can deduce the percentage of time the non-compliance is occurring. So we can also develop river loading capacity, continuous database update, and also as an early warning system. Now, we are able to integrate the system with the GIS or the Geographic Information System to map out where are the sources and the non-point sources, okay? And we can use it also as a prediction for the non-point sources using the LTR model. And of course, whatever the clients need to integrate with the system, we can always do that. So that is the beauty of using the AI actually. Of course, reporting comes as the final output. It can come in whatever format that the user wish to have. Now, this is the architecture of the whole river pollution load analysis system. You can see here we have automatic monitoring stations. Of course, being real time, it has to be an automatic monitoring stations. You can have as many stations as you like. And then you can go to the smart data logger and the IoT protocols, of course, and we have to have the firewall, okay? And then this is where the whole system, the analysis, the processing of the data goes under this cloud system. So we are integrating, you can see here is the GIS and also the model, prediction model. So all these are driven by the AI technology, and yeah, the other output will be, you can see it's real time. You can develop it as early warning system. We can generate reports. We can have forecasting and modeling, and we can have security map. All kinds of things can be done according to the user requirements or whatever the clients request for. Now let us to share with you some of the outputs from the system. Okay. Now, all right. This is a screenshot. Okay. So we are not able to demonstrate to you the real time, but if you wish to see the real time, you can always contact us so that we can demonstrate to you the real time. You can see that the data is running, the analysis is running in real time. So it is displayed here what you call all the parameters that is being measured every second or every minute, and then it will gives to you the outputs. Okay, you can see that there is TDS loads, you can see that there are stability loads, you can see that there are nitrate loadings being computed every hour. And you can see anything above the blue line, okay, anything above the blue line is the violation. So you can see that stability loads, okay, let's take example the stability loads. So you can see that there are violations in terms of the stability loading at that particular hour. And you can see that the stability loading comes from the non-point sources. So at the very beginning already, you knew that the violations come from non-point sources. So this is where the spatial data becomes very important for us to identify what's next when you know that the sources of stability loading is coming from the non-point source, right? So so you can see there is another table up there. It lists down all the parameters that it is measuring. It gives you the concentrations, okay? The concentrations and the loadings and the flow in real time, right? Now let's look at the next screenshot, okay? Now this is the loading capacity. If you look at the blue lines, okay, it is the loading capacity of the river. It gives you the segregation between the non-point source and the point source. And if you look at the colorful one, which we have is actually the flow characteristic. Now we have developed it into 4 characteristics. One is the highest, which is in the red color, and the lowest, so the low characteristic or the low flow in the blue color. So in between is between moist, between the dry conditions, okay? And you see that the non-compliance of the turbidity occurs during the moist conditions of the flow, all right? So that is another piece of information which is very useful now that we know that it is happening during high flow actually, right? Okay, this is the full screen to show the analysis of these pollutant loads are based on the National Water Quality Standards. So you can see there is a drawdown on the current status for what class you can choose, which class you want to see the trends in the pollutant loadings, and so it gives you the readings as you like. Now again I want to highlight to you, if you look at the colors, okay, the red color, the brown, yellow, green, and the blue colors, okay, these are the flow conditions, and the one that is on the graph is showing you the non-point source and the point source, okay? So it integrates everything in one piece of a screenshot that you can quickly look at it and make an interpretation of the current situations of the river right now, okay? Now, all right. This is how we develop the early warning system from the color codings, okay? Now let's look at the turbidity, okay? Now look at the pie chart on the turbidity, okay? So now the turbidity is, when it's blue in color, it's normal. And yellow, we start to say there is something not right, there is going to be a violations, and the red one is the accident, okay? So from there, we can already develop at what percentage do we want to decide that the early warning system must be developed. So this pie chart gives us the idea of how we should come up with the early warning system for the parameters that is chosen for. Okay. All right. I mentioned also that we are integrating the system with the GIS. Okay. Now in GIS we have data, spatial data. Okay, and it gives you the sources of pollutions. So if you look at this particular monitoring station, we have the non-point source from animal farm. We have the point source from the palm oil mill. There is individual factories. There is industrial outfall. There is landfill, sand mining, workshop, etc., etc. So all these are maps in GIS. So we already have an idea what are the non-point source and the point source of these particular watersheds. Okay, right. This is the integration part with GIS. We determine the sources. Okay. Now, if you look at the prediction model, the LTR that we are using, it can gives you the idea of if what happened if we change the land use. What is it going to be? What happened if we remove some of the plantation? What is going to happen? What happens if we remove the trees? What happens if we have more impervious kind of surface area? So this is the prediction tools that we can use, okay? And you can see that it will give you the result in terms of the parameters that you are talking about, right? So this is the prediction model. All right, I think I have come to the end of my session. If you wish to see the real-time demonstrations, please contact us through our communication notes here, whereby you can visit our website, it's enviromalaysia.com.my, or you can go to our FB, Alam Sekitar Malaysia Sendirian Berhad, or you can make inquiries through these two emails. One of them is my email. So with that, I thank all the audience for sharing their times and for taking the time to listen to what.
Ladies and gentlemen, we have come to the Q&A session. If you have any question, please click on the hand raise function and the organizer will unmute you, or you can list your question down on our Q&A chat box. Please make sure introduce yourself and which company are you from, follow with your question. So we will wait for a while if we have any question from audience. Okay, looks like there's no question from the attendees. We have come to the end of our third session today. If you have any other inquiry, please visit Alam Sekitar Malaysia Sendirian Berhad virtual booth in our virtual exhibition hall. That's all from us. Once again, thank you so much.